Welcome 5th graders to lesson 6, session 2 in your book, starting on page 125. Today we are developing our understanding of decimal place value. So we're getting smaller than 1 here on some of these things. So you're used to these kind of big dealios representing 100, and there are 100 little boxes in there, but not each little box is 1 this time. We have taken the little 1 cube and we have zoomed in on it to see it now broken up inside into decimals. So each of these is now a 100th. So we're going to, for the first problem, for our model it, we are going to, can I make my highlighter smaller? I don't think I can. Whatever, it's small enough. Okay, so if each of these boxes is now 1 hole, just zoomed in, and this is 3 holes, I need to color in 3 whole boxes. You don't have to stay in the lines, I forgive you. There we go. I can color in 3 whole boxes. Now for B, we have 3/10. So this is like kind of like the tens place. So we're going to make kind of tens sticks going on. So I'm going to color in 3/10 of my 1. 1/10, 2/10, 3/10. For figure C, we have 3/100. So now these are when you cut the 1 cube into 100 tiny little pieces. So we got 1, 2, 3. Or you could do it from the other side. You could have done it over here. It doesn't matter which 3. You could even do 1, 2, 3 if you want to be crazy. Don't be crazy though. Not today. 1, 2, 3. I'll do those 3. There we go. Okay. Complete 4 different equations that show the relationship between the numbers and between the numbers shown in the models A, B, and C above. Okay, fill in the blank. I'm going to take my C, the 0.03. If I multiply that by 10, all you have to do when you multiply and divide by 10 is move the decimal. So multiplying by 10, I must move my decimal over a place. So now it's 0.3. The decimal's moved over here. I could also take my now 0.3. If I multiply that by 10, again, I'm going to move that decimal over. It's just 3. I'm going to take my 3, and I'm going to divide it back by 10 again. So now I need to move the decimal, but since I'm dividing, I'm moving the other way because I'm getting smaller. I don't see a decimal there. Where is it? Oh no. Oh wait, it's just right there. Just like when you have $3, I have $3. Where's the decimal? It's right there. It's at the end. So I'm going to take that now invisible decimal. I'm going to make it visible, and I'm going to move it 1 space to make my number smaller. 0.3, which is the same as 0.3. Put the 0 there if you want to. I'm going to take my 0.3 and I'm going to make it smaller by 1 place value. I'm going to move that decimal over there. So now it's 0.03. You can put the 0 there if you want to. It does not matter. Number 3. Finding 1/10 of a number is the same as multiplying the number by 0.1. Complete each sentence and then write the sentence as a multiplication equation. So 3/100 is 1/10 of, so we took a number, we took a number and we multiplied it by 1/10, or by 1/10 that way, and it was 0.03. Didn't we do that up here? Multiply by 1/10. Multiplying by 1/10 is the same as dividing by 10, so that's going to be 0.3. 0.3. 0.3 times 1/10 is 0.03. Let's see, what is 1/10 of 3 now? 1/10 of 3 is 1/10 of 3. So 0.3 equals 3 times 1/10. And I'll write 1/10 the other way this time as a decimal. I can do it either way. Number 4. Use a number line to show how decimal place values are related. A. Fill in the missing labels for the red tick marks on the number line below. Okay, I can do that. So we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.8, and there's no, they didn't put 0.10, did they? No, they did not. It's just 1. 10/10ths is 1. I've got, for my tiny space number line, this one is 0.2. This one's 0.3, so this one's going to be 0.40. I don't know why they have another 0 there. That's totally not necessary. I'm not going to put it. Neener. So if I'm going this way again, it's going to be 0.1. I'm going to leave off all the extra zeros now. 0.5, 0.6, 0.7, 0.8, 0.9, and again this is 1. 1.0 if you prefer. And then B, place a point where the whole number 1 on the first number, place a point for the whole number 1 on the first number line. Okay. There we go. So the whole number 1 on the first number line. The decimal 1/10 on the second number line. Okay, 1/10. There we go. And the decimal 100ths on the last number line. Okay, 100ths. Okay, this is 1/10. So this is 100ths right there. There we go. Try doing another color. I'll do it in another color in case you can't see it with all the red. There you go. There you go. There you go. 100th. It's a penny. 1/10 is a dime, and 1 is $1. Number 5. How does the distance from 0 to 1 compare to the distance from 0 to 1/10? So the distance from 0 to 100th. Okay, the distance from 0 to 1. Then the distance from 0 to 1/10. Then the distance from 0 to 100th. How do they compare? Where's my typing tool? The distance, oops, I'm going to change that, make it bigger, hang on. 1 is 10 times as far from 0 as 0.1, oops, and 100 times as far from 0 as 0.01 is a penny. Number 6, how do decimal grids and number lines help you understand the relationship between adjacent place values in our number system? So how does this model and this model help you understand the place value of these tiny numbers? That's really the kind of question that you should answer yourself, because it's how it helps you. So I'm going to give you the answer that the book gives, just because it's not a personal answer. And you should rewrite it in your own words in a way that is honest. So here we go. Ooh, why did it change the font? Hang on. Okay, I don't know how to change the font. Whatever. With decimal grids, you can see that a model for a number is 10 times as many squares as a model for that number with its digit moved one place value to the right. On a number line, you can see that the number is 10 times as far from 0 as it would be if its digits were moved one place to the right. If that doesn't make sense to you, then don't put it like that. Word it in a way that makes sense to you. How do the models help you? Number 7. How many times as great is the value of 1.5 than the value of 0.15? So how what's the difference in the decimals? The decimal's here, the decimal's there. How many times did we move it to get it from 1.5 to 0.15? We had to move it one time. So how many times as great is it? 10 times as great. And we need to explain why. How can we explain why? I'm going to type that one. When digits move one place value to the left, it's like multiplying by 10. Okay, so that's it for me. You go ahead and work on your practice on your own. Good luck.